Hi, my name is Ari Sulaiman Alfian. Today, I have for you the paddy field and growth stage mapping using satellite imagery and machine learning for my submission for Eureka. This project is supervised by technologist Dr. Fatin Ayuni Azizan, and the industry advisor for this project is SD Gatri Agrotech. Now, this project complements the SDG of Zero Hunger, SDG number 2, decent work and economic growth, SDG number 8, and industry, innovation, and infrastructure, which is SDG number 9. So this research tackles the challenge of monitoring Malaysia's rice granary in Perlis by moving beyond traditional and labour-intensive field surveys. By integrating planet-scope, high-resolution satellite imagery, along with vegetation indices such as NDVI, which is derived from the satellite imagery, paired up with machine learning via RStudio, this study provides a scalable solution for real-time agricultural assessment. Now, the problem statement for this project is the traditional monitoring is labor intensive and the low visibility of satellite images due to cloud coverage. Now, in terms of the novelty and innovation, this research focuses on temporal identification of specific growth stages, unlike most researchers out there with a similar topic. Now, this project also proves classification of critical stages including seedling, tillering, panicle initiation, flowering, and finally ripening. Now, the advantages of this project is its scalability, its open source accessibility from via R software and PlanetScope, and finally precision management, which I will cover in a little bit. Now, in terms of its commercialization, real-time granary oversight, yield prediction for food security, and crop health monitoring, which again I will cover in a little bit. Now, in terms of the commercialization, this particular technology can be used, it is most suitably used by agricultural agencies such as MADA, IADA, and so on to control irrigation and fertilizer distribution. Now, one of the advantages discussed earlier, open source accessibility, this means that it offers a cheap solution, as the open source accessibility of RStudio and PlanetScope allows this to be a cheap option for agricultural agencies to use to monitor paddy fields in the surrounding areas. Now, let's look at the results. So, as you can see here, this is the NDVI profile in different stages derived from the results obtained below. Now, if you can see here, as you can see, in the germination stage, the NDVI temporal profile is at its lowest, while it increases steadily up until the flowering stage, approaching the milk stage, where, as you can see, it plateaus just a little bit, approaching until it approaches the maturation stage, which then the paddy plant will be harvested. Now, this is proven from a study that I've conducted using PlanetScope imagery, which I processed using RStudio. As you can see here, in order, the first picture shows an NDVI average of negative 0.003199, which then increases steadily up until the dose stage where it dips. The NDVI average dips. Okay, it increases steadily and then reaches a plateau and it dips. Okay, so how machine learning can be applied to this technology? Well, if one was to obtain an image through satellite imagery sources such as PlanetScope itself, by using a machine learning model such as random forest or support vector machine (SVM), it could determine at what stage that particular paddy field is at, with minimal effort at that particular time. Now, this helps in identifying the suitability of irrigation management and fertilizer distribution. Now, the technology readiness level of this particular technology is rated at a level 3. That's all from me. Thank you very much.